So I want to introduce Dr. Lover and James, who will be presenting today. They're going to be presenting on one of their uh, tick studies and looking at some spatial data that they were collecting, but they'll talk more on that. So I'll open it up for Andrew or James to begin as I admit
Cool.
people.
Hey everyone, great to be here and thanks for joining the call. So it's very much a work in progress. So we're talking about some ongoing and preliminary analyses we're doing from some data we collected over the last few years. So let me jump in. Okay. So the impetus for all of this was thinking about this so-called Pareto rule, where a lot of different infectious disease systems show this distribution where 80% of events happen in 20% of the population. So in many cases, for at least for parasitic systems, a small number of hosts have the majority of parasites. And for a lot of mosquito-borne transmission, like say malaria, a small number of infections are responsible for the vast majority of transmission. So this combined with the thought that we don't have a great sense of where most domestic tick-borne disease transmission happens, whether it's domestic or recreational, plus the idea from talking to local clinicians that they seem to see the same trailheads when people talk about where they think they got their tick exposures. So the idea here was, can we put all of this together to, basically use people with tick exposures as probes of the landscape to identify places with potentially highest risk. So this was the general design. We're calling it a spatial case control. So the first part was just a general case control, collecting demographics and general risk behavior and knowledge, attitude, practice kind of questions. And then the spatial control was set up to detect at least 7 statistically significant clusters. So this is spatial locations with unusually high or low tick risk relative to the background. And then the plan was to then do intensive tick sampling at the elevated and cold spot locations to then compare the tick densities and pathogen prevalence, along with some hobo data loggers and some kind of standardized tick drags. So the actual flow of patient enrollment was through local clinical sites. So this is for both tick-borne disease cases and controls. Then we would give people a GPS data logger for 3 weeks after a washout period, just to make sure they recover from whatever their illness was. And then we'd use all of those data to try and identify highest risk locations. And that could potentially allow you to target kind of expensive, difficult, and labor-intensive interventions to those specific areas where potentially most people are getting their exposures. So the case enrollment criteria was either an attached tick or confirmed tick-borne disease, more than 1 year old, and then we limited this spatial scale to the 2 closest counties. And this was just to make sure that we had enough kind of density of spatial locations to make a reasonable analysis. And then the controls were anyone with similar demographics, but without a tick-borne disease illness or attached tick or tick exposure. And then also no current comorbidities that would impact their mobility, because we really want to try and measure the ways people were using outdoor spaces. So the original data collection was supposed to start in the very beginning of COVID, and we had a whole slew of delays, and this was just based on the local clinical sites not having any ability to even think about working with us. So we finally were able to start implementing in May of 2022, and then we had 2 years of data collection through just recently. And so the original design was for us to sit down with clinicians and do EMR review to identify recent ICD-10 codes related to tick-borne disease illness. Because of all the pandemic challenges in terms of staffing, that was not possible.
Andrew,
So we did.
Hey,
Sorry, go ahead.
are your slides supposed to advance? We're not seeing any slide change.
You're not.
Oh, there it is now. Thank you.
Okay, so let me. Did you see any of these slides or just this first one?
No.
Someone should have spoken up much earlier. Oh, I see the raised hands now. Okay, so this was the general design of looking at the Pareto distribution. This is some of the data looking at this was the original design with the two different types of conventional case control and a spatial case control. The patient flow here, so I'll just quickly reiterate. And then this was the inclusion and exclusion criteria. So as I said, we were originally planning on doing really detailed EMR extractions and then working with clinicians to specifically invite participants, but that was not possible due to staffing issues. So we had this poster and a lot of file cards or postcards, which were given out by clinicians to anyone that was interested or who had a recent tick exposure. So through the enrollment process, we had 634 people who completed the initial screening. Just under 600 provided consent and demographics. And then from that, 237 people completed the full survey. Then I'll have James is going to talk a little bit about the spatial analysis and some of the data sets there. So one of the big things we wanted to think about is exactly who we enrolled and how representative they may be of the general population. One of our clinical sites was the University Health Services here at UMass. So there was a bit of a concern that we would maybe kind of artificially enrich it in 20-year-olds. So we did have a reasonable number in the undergrad age population, but the vast majority were middle ages and then another peak in close to retirement age. And the ranges were from 1 to 84 was our oldest participant. We also had a good spread in gender, which was good because very often you have a large number of females who will participate. We also had a nice spread across different clinics. So one of these is a pediatrician clinic. So there was children, which we were quite happy to be able to enroll and get data on spatial mobility of younger kids. And then geographically, there was a nice spread across the region to get different towns. Then looking at the demographics of our population and the general attitudes relative to a larger sample. So on the right here is from the Itch KAP survey. And you can see the vast majority of people are in the two top categories of somewhat agree or strongly agree with the statement that ticks are a big problem for me and my family. And we see a pretty similar distribution on the left of the participants in this case control study, with maybe a bit more people in the neutral category. So again, the categories are not completely comparable, but you can see the general levels of concern are similar. We also really hoped we would be able to capture people who have enough outdoor activity to make our data meaningful and useful. And so the question here was, how often do you do any of these activities on nature trails? And a small set of our participants said, never or almost never, but the vast majority were in this at least once a week. So we have a reasonably young and fit population that are doing enough outdoor activities to have measurable levels of tick exposure, presumably. So these are the trackers. It's called an I Got You, and they're a data logger. And so the data are stored on there, but there's no transmission. And so when people return it at the end of the study, they have the option to have us delete the data, which I think was really important for some of the participants, as well as the IRB. And I should also note we have 70 or 75 of these that we're not using. So if anyone sees any opportunities, they could build on this kind of work, we're happy to talk and find a way to use them. So we wanted to make sure that the trackers themselves were not a barrier. I mean, if people, thought it was a huge burden and didn't routinely carry it, they probably, our data might be not as reliable as we hoped. So almost everyone were in the very easy or somewhat easy to carry categories, and then a few people did have some challenges in terms of carrying and charging, because it does need to be recharged on a semi-regular basis. And then we also asked for their self-reported usage for their routine activities while they were part of the study. So gratifyingly, a huge proportion all used or reported using it almost all the time for their outdoor activities, and then a few people probably were happy to get the gift card, but didn't necessarily contribute a lot of data. But since we have the tracking data, we can validate this to some level. So altogether, this really supports that we had a active group that had reasonable levels of outdoor activity during the study period. And then we have a whole slew of other questions asking the same groups about personal protection and activities around their house, as well as outdoor activities like hunting and fishing and bird watching. And I have a surprising number of hunters. There's maybe 10 or 12 people that hunt routinely, which is a demographic we don't have a lot of data on. We also had their self-reported amounts of seasonal variability in hours spent outdoors during spring, summer, and fall, which is when we would expect to have exposures. And then some general knowledge questions about tick-borne disease and any potential recent exposures in their household or family. So we're currently working on modeling factors associated both with a confirmed tick-borne disease as well as tick exposure. So there's two different outcomes there. Okay, so that's my part of it. Are there any questions on that first section? Yeah, Steve.
So, do you know who was actually bitten by ticks, or is just the presumption from a positive serology, or how did you?
No, so we have their self-report. And so there's a subset where their original presentation at the clinic was for tick-borne disease. And then there's a larger set that said they've had recent tick exposure.
Did I know what kind of tick, or did you ask that question?
We did not. I mean, I think in general, that's not always super reliable. So that is a limitation. But if we're looking at tick exposures broadly speaking, then it's yeah. Any other questions on that part of it? Okay, I'll hand it off to James, who's going to talk about the spatial case control analysis.
Well, thank you, Andrew, for that. That was actually a really good introduction to our study. I can share my screen. Hopefully everyone can see that. But yeah, so on the more mathematically centered part of the analysis, after we've collected all of the data, we've worked with it, and uploaded it so that we can work with it further with the statistical software that we have, we're actually able to do a lot of really cool stuff with it. So let's see. So essentially, with all of this data that we were able to collect, we could then try to find areas that had more or less people present in them based off of the GPS logger data. These people would be walking their dogs, going for hikes, and going to all of the places that they may or may not be contracting these ticks. And I can totally understand the vendetta that some people might have against them and so actually taking action and joining a study like this is really cool. And so we can actually find a lot of locations that will save us a lot of time and money to do treatments typically on trails, where we have the most ability to do these kind of studies. So once we collected all of the data, this is kind of a snapshot of what it looks like as from an overview standpoint. We have probably the most amount of people within the Amherst and adjacent areas, but as you can definitely see from this, people are pretty active. Most people have cars and are going around to their respective hiking locations of preference. And so we, at the end of the day, are trying to filter out all of this, I guess, GPS tracker data that is pretty messy at first and bring it into a more usable format that we can then use to, um, I guess, like uncover these hotspots or areas where of concern for us for treatments and beyond. Going from this to something a little bit more usable brings us to a lot of, I guess, decision-making steps that we have taken to, I guess, bring it to something more reasonable. So there are some degrees of limitations with our filtering decisions, but at the end of the day, it becomes very computationally limited by the current hardware that we have available to us. So boiling this down to the bare essentials is absolutely necessary. And that was the first step in our quest to kind of get hotspots from this. But again, a huge distribution of points. People are going out far and wide, and hopefully we can find the areas that do have a good concentration of ticks based off of our sampling. Um, so yeah, we started off by trying to remove highways, main roads, buildings where people might be idly hanging out at throughout the day. I'm a homebody myself, so I fully understand how that can be really nice at times, but we're mostly interested in the people who are going out and about. So filtering out within a certain range of buildings. So we took building footprints, buffered them by about 10 meters, and removed all of the points within those areas. Idle data was also removed. So we have timestamps for every GPS point that was recorded. And so we can see that if there is just a long breadth of time between each point that's being logged, we can then remove it. These points are not as helpful as these people aren't actively moving around and are very unlikely to actually be getting any ticks. And yeah, we also removed car data from roads. So we were able to buffer highways, main roads, and substreets by a more, I guess, accurate buffer size, respectively, for each. So highways have a pretty big buffer. Meanwhile, main roads and side roads have a little bit smaller buffers. And yeah, so we were able to then boil down the huge cluster of points from our initial data set. We're talking about a few 100,000 points. On average, I think it was about 42,000 points per person, but it very much so varied from participant to participant. And then we can use this data to uncover tick hotspots in Western Mass through these methods. I guess just for some numbers, I know there's a lot of text here, more for the data junkies on that front, but we started off in 2024 with about 300,000 points, and after filtering, we get to a much more manageable 160,000 points based off of this filtering. And based off of the season, you can lose certain participants who may or may not have had enough data associated with them, but this is very normal. There are a few people that just didn't really, for either technical reasons or for their own activities reasons, they didn't have as many points, as the GPS logger typically is based off of movement. And so after filtering, we are getting to a much more manageable amount of participants and sizes. And this is just for 2024. Each year has a bunch of them. And so if you can see what we start off with in just 2024 and then extrapolate to when we started from around 2022, 2023, you end up with a very, very large data set. And so this was really cool to be able to kind of see play out with the numbers. But yeah, so after doing a degree of filtering, which I've probably beaten to death at this point, we can then finally bring it into SAT-SCAN, which is kind of our epidemiologically standardized hotspot software, which uses a bunch of well-used and well-practiced metrics and algorithms in order to uncover these hotspots throughout space and time, as the option that we ended up going with. And it would have actually been incredibly difficult to do this if it was not for the R SAT-SCAN package that has allowed us to script and automate a lot of these very intricate analyses with a lot of settings and filters and add-ons and a bunch of statistical, I guess, logic that we've had to use at the end of the day to make this possible. And we are definitely stretching the use case for SAT-SCAN, but hopefully pushing the boundary can lead to something a lot cooler down the line. And yeah, so it's been really fun coding it out. If you're not familiar with R, it is a statistical coding language mainly used by biostatisticians and beyond, but it's honestly probably my favorite, and it's been really fun working with it. But the models do take quite a while to run, and the amount of permutations that we ended up doing is actually quite substantial. So we were running these models by years and by seasons as well, in order to do as much or as close to a sensitivity analysis on that front. So making sure that all of the hotspots that we're generating is not exactly a fluke. We want to make sure that throughout the seasons and throughout the years that these hotspots are relatively consistent. And because of the amount of model permutations that we're looking at, so we're looking at about 20 to 25 different model permutations that could be done. Having it automated all in R is actually really awesome and was a pleasure to have instead of manually going through the user interface that SAT-SCAN has by default, which is still very good, but definitely a bit more difficult when you're doing this many types of analyses. And we were then able to find hotspots, which are pretty much concentrations of points in a space, and then determine the nearest hiking trails near to those hotspots. So we're thinking these people are in parking lots or in areas next to these trails that may be harboring tick populations that we'd be interested in treating. And then isolating these hiking trails so that we have a list of places to end up sampling at with tick dragging to end up finding more advanced population and vegetation information about these areas, which is really cool. And it has a lot of real impact once we're able to kind of boil it all down and take action on it. But for our model type, we did a retrospective space-time analysis. And so this was mainly chosen because I like going out into the field myself and with some of our people in the chat right now, you can show up to a place 1 week and get a bunch of ticks and show up the next week and get absolutely nothing. So having a space-time component is probably makes the most sense for this specific use case. And then we were able to scan through timeframes of 1 to 2 week intervals and see if there is consistently a hotspot generated in these clusters of points throughout time, throughout the years and seasons that we end up running the models on. And so these were run through a Monte Carlo replication 999 times, which can take a little bit, but it ensures that we are getting the most accurate hotspots, statistically speaking. So we're making sure that we are not just getting a fluke of a hotspot at the end of the day. So some really cool math under the hood, but I won't bore you with too many of the details. This is more for, I guess, the holistic view of things, but we are considering space-time in order to generate hotspots that are, I guess, more ecologically relevant, which is really cool, especially as we have so much data to work with. As Andrew talked about earlier, we have those with the vendetta who have come in with our with attached ticks as their reason to join the study, which is the restricted cases. And then we have more general cases of people who have, since starting the study, they have gotten a tick in the areas that they typically go to. Meanwhile, we have our Good Samaritans as controls who haven't actually had an attached tick, but believe in the cause. So they are really useful for making sure that our case data is not just a fluke. We're using different ratios of cases to controls in our models in order to make sure that nothing's happening just by chance. So we can get a better idea of what's happening in these areas. So you can probably see by now how many different permutations of models we are ending up running. So we are having a huge list of years, seasons, combinations of seasons, and then ratios of cases to controls. Of course, we always are going to be looking at just the case data and see if those hotspots get generated. And as we start introducing controls, we're just making sure that as the controls enter, people have not had ticks before or during the study, that the actual hotspots remain consistent and that they aren't getting dropped just because of the controls. So it's a general trend that we're trying to isolate. And it's some form of a sensitivity analysis, but I guess it makes more sense once you start seeing it. This is just a little snapshot of the, I guess, the model permutations that we've done. So the Meta-Comet Monadnock trail is actually very popular with our models. So with many combinations of cases and controls, we are finding that the Metacomet Monadnock trail is very popular for ticks in our cases. And even once we start introducing controls at a 1-to-1 ratio and even a 1-to-2 ratio, you are starting to get more and more validation that this trail is a bit concerning, and that we can then end up going over there and doing tick sampling establishing sites and making sure everything looks good to see. And for those hailing in not from Massachusetts, it is this mildly Halloween themed map that I kind of whipped up before this. So it's mainly throughout Western Springfield, going up into Holyoke, and we get some of it near Mount Tom and Skinner State Park. Because it is a more widespread trail, it kind of bounces in and out of the Robert Frost Trail and a few others that are spread out throughout this range or the Appalachian Trail, which is really cool to see. So they seem to be very popular and people are getting a lot of ticks there. So we can then say that, hey, all of these models that we've run in many different permutations have consistently told us that there are dense clusters of points from these GPS loggers very close to or near and on top of the trails of interest. So the Metacomet Monadnock Trail seems to be a very popular one. Although this is kind of our halo example. Typically we get ranging from 3 to 7 different repetitions of certain trails. So the Lake Pleasant Road had 3 models that consistently were identifying it as a hotspot. The Francis Ryan section of the Norwottuck Rail Trail had 4. And so as we are kind of looking at this table, we can see that, like, at least for the Metacomet Monadnock Trail, we're looking at our restricted case and general cases in fall, spring, winter, and combinations of winter and spring through multiple permutations and runs that it's all being shown. Even when you isolate the general case from the restricted case, all cases at the end of the day, we're really consistently seeing that the Metacomet Monadnock Trail is of interest. But this is just one example. We have a good list of trails kind of in the works, but all at the end of the day need more validation. And it is a work in progress. So I guess take it with a grain of salt, but this is one of the cooler ones that I thought to show off. So I've been talking about hotspots for a while now, but you probably haven't seen them yet. So this is kind of a little snapshot of a map I made a little bit back. But this is essentially kind of showing off the different areas that have hotspots generated. So you can kind of see in the zoom in that we are getting these red hotspots next to trails, which are the dashed lines. And so people are parking and going on these trails or are walking in clusters near the trails. So investigating what is going on further in these areas is really cool ecologically speaking, which is what a lot of us are going out into the field to kind of check out. So tick dragging, vegetation surveys, and collecting more information about these areas near the trails. The hotspots are very much so a proxy. They are not perfect and are definitely more of a pointer rather than a very specific location. And so you're seeing that some of these are just near the trails, but that still is really useful information. So the people that we are working with are likely going on hikes here and spending time in this area. So as I talked before, there are some technical limitations to our analysis, as there is with everything, and that's why this is a work in progress. We are definitely stretching the use case of SAT-scan. This isn't the traditional way that we would want to end up using SAT-scan for a lot of epidemiology or ecology, but I think it's really cool that we're kind of thinking outside the box a little bit and working with this software. But it can be buggy, and because of our, I guess, very specific um, filterings and model settings, we are going to run into a little bit of an issue with a little bit of it. And so we haven't really been able to clearly identify hotspots and cold spots um, due to some of the buggy nature of SAT-scan. They end up generating what is expected to be in the hotspot and what is actually observed. Although at the moment, I am trying to debug and see if we can work around it to try to get SAT-scan to figure out what the observed cases are. Um, this is a bit more technical, so if you have more questions about this, I can try to answer it at the end. But we are trying to get a better understanding of hotspots and cold spots. Although the way that SAT-scan ends up showing off these hotspots and cold spots um, is more of a sliding scale. So it's like this hotspot may or may not be more strong than a comparable hotspot near it. Again, more math than you probably asked for, but it's a work in progress. So we are trying to work our way through it. Additionally, there is computational and hardware limitations. Um, most consumer motherboards can't handle more than 120 gigabytes of RAM, which is essentially your computer's temporary storage that lets your computer run. And SAT-scan eats up this RAM like it's nobody's business, and especially when you have a few 100,000 points, it's gets eaten up pretty fast. So we're considering working with UMass and more clusters that have more RAM and more capability to run larger models. And each model can take up to an hour to 3 hours to run, depending on the model settings that you end up choosing. And so with the amount of permutations we're working with, plus the runtime, it can be quite daunting. And so going forward, we're going to be trying to get the cluster, try different hotspot options, tweaking settings, playing around with it a little bit further as we wrap up the season, and also trying to grid our data in order so that the runtime, RAM usage, and model settings can more accurately reflect the landscape in an actual reasonable amount of time. And so hopefully this was helpful, and I'm more than happy to answer questions. I know it can be a little bit more technical, but thank you for listening to me ramble for a little bit.
I have maybe a very silly question, but how does this tie back into to the Pareto? What's distributed?
So the idea is that a small number of trailheads may be the source of the majority of infections. So the human tick overlap may occur at a or the majority of tick human exposures may occur at a reasonably small number of locations. And obviously that's quite different from looking at the distribution of parasites, but human use cases mean that, trailheads are, if you looked at like the distribution of, there's a lot of trailheads that very few people use ever. And then there's a lot of trailheads where a ton of people use. So it's, that was the general thinking. And then that gives you a handle to do more intensive interventions, because obviously we can't do, really intensive interventions across all of Western Mass. And this is just a way to prioritize the tickiest or areas with the highest tick human exposure risk.
Is just the trailhead just a good approximation of where the exposure, and then we assume that the distribution is more uniform of the vectors themselves?
So you're saying, is the human use density different from the tick density?
I'm just wondering if, based on what we've seen, ticks are pretty much everywhere now.
Mhm.
Maybe the difference in exposure is just if a trail gets 100 people a day versus a trail getting 10 people a day, that's a higher exposure at the 100.
I mean, so the interface density is different. Yes. The actual tick density in places no one goes is irrelevant. But if there's a much higher human use, then the risk is probably higher.
Mhm.
Yeah, so for example, the Metacomet Trail seems to be very, very popular with a lot of our participants. And so that would make it a really good candidate for sampling and potentially treatment down the line. And so being able to isolate these trails in general, it's not necessarily the trailhead by any means. It can be any point along the trail
Mhm.
that the hotspot can be in proximity to within around 500 meters. And so we can get a good idea of if this trail is being used a lot, and then taking action from there.
Thank you.
Nita, I saw your hand was up, but was your question answered?
Sort of, yeah. I think I just wanted to clarify. So the purpose of the hotspot analysis is to identify public places where people may be exposed, right? And then because if by filtering out residential properties, you sort of omit the potential exposure there, which we believe is probably pretty common. And so I was just wondering about how much what is that filter around buildings? And if you, did you do anything to would you consider taking your residential buildings and treating them differently than maybe your, more commercial areas, or maybe, or is it just really, is that not the point? Is the point more about these public locations where you have a lot of human activity? It's really, you're showing hotspots of human activity. And then my second question was just about, could it be, is it just every person's visit, or could one person visit the same place multiple times? And does that matter?
Yeah, so going backwards, the multiple visits by the same person on different days are just a measure of use, population level use. So people can contribute multiple data points. When we grid it back, we're talking about trying to grid it out so that there's a 20 or 30 meter grid, and then each person will contribute maybe a few data points to that. The other thing is that the resolution on the trackers is, 5 meters, but it can also bounce around to 30 or so. Like sometimes you'll see data points that are just way off. And so around all the residential sites, there's this, some people just turned it off when they came home. And so there's very little data density around their house. And then other people kept it on all the time or took their dog for a walk, and you see this kind of star pattern around their house. So most of those points are included. It's just the ones immediately adjacent to the house. I mean, some people have 20,000 data points like inside their house or next to the window or something. And so the distinction between paradomestic and kind of neighborhood level, well, we can definitely do some analysis there to see where a reasonable buffer is. But some of the yard sizes here are quite small.
Yeah, and so then just to follow up on that really quickly, is there a time element that can be a part too? Because maybe the time spent in those more locations in the neighborhood, maybe, it may weigh more. But again, maybe the point is not, we don't care about.
Yeah, I mean, so
the
the original,
property.
yeah, I mean, the desire here was to try and find publicly accessible places that would potentially be high human use in tick-prone areas.
Yep. I get it. That makes it much more clear. Thank you.
I mean, I think, the challenge is that we don't know if people's exposures were more paradomestic or recreational. Yeah.
Yep. Thank you.
Lars?
Yeah, I was just wondering, based on the prospectively gathered information, if you could move from just comparing no tick to at least one tick to something that was more stratified, because you might have some people that have one tick, you might have some people that have
Hmm.
5 to 10 ticks, but that would require having that prospective information after the initial entry. I was just curious about that.
Yeah, so at the end of the survey, we did ask them if they had any tick exposures during, so we enrolled them and there's a washout period, and then we sent them the tracker and then they collect data for a few weeks. And at the end of that, we asked them if they had any challenges with the tracker, et cetera, et cetera. And one of those questions there is, did you have any tick exposures while you were carrying your tracker? So we could definitely incorporate that and maybe stratify on that and see if there's anything else there. So that's a little different from your question in terms of the actual number of ticks, but at least we have some more temporally recent data. And I should say, so one of the assumptions of this whole study is that people's recreational activities after their tick exposure are reasonably consistent with the data that we would have liked to collect before their tick exposure. So that's one inherent challenge that we just have to assume that people's activities are consistent. Pat?
Yeah, I was wondering, based on your model and your groups, were you ever able to discern differences in popular trails? And like by that I mean, was it always the case that popular trails had a bunch of hotspots or were considered hotspots, or was there ever a case where you had one popular trail like the Trail has a bunch of hotspots, but then you have another popular trail which has less hotspots or no hotspots?
Right. So you're wondering if it's just a function of usage and not actual risk?
Yeah, like are all popular trails hotspots?
Yeah. I guess we don't have great data on trail usage in general. I mean, we can look at like within our data set, the trails that people use more regularly. I'm not sure how we really get at that question. And in some ways for the potential interventions, it maybe doesn't matter. In the sense that we want to understand that if there's a high risk trail that no one uses, then we don't care.
Yeah, I guess I'd just be interested if there was a really popular trail that didn't have any hotspots. Like that would be interesting.
Yeah, I guess, I mean, we can try and map out the like 3 or 4 highest density trails and then see how many have hotspots. Yeah, that's a good idea. Yeah. Tom?
You're muted, Tom. Here, let me unmute you.
Just following up on that question for a second, couldn't you do that just by looking at the people that weren't bitten by ticks and seeing what the popular trails are based on
Yeah, I
that?
mean, so that's built into the case control part of it. So we're comparing trail usage between people who had a recent attached tick and those that didn't. But I think that's maybe Pat's question was maybe a little bit different in terms of population level usage of the trails.
My main question, though, while I was waiting in the queue, was that could you associate like different clinics where the patients came from with just geographically there might have been some kind of a more likelihood? So you had one clinic that had the most people participating, for instance, and was that geographically near to the M&M trail?
No, there's a lot of geographic spread in terms of the home locations and activities. Yep. Yeah. The clinics all have a really big catchment area, so there's not a huge partitioning.
Okay.
Yeah, like with the amount of points that are generated, especially in the Amherst, Hadley, and adjacent areas, it gets very, very dense very quickly. And so I'm not even sure if it would fully pop up either.
Thank you.
Steve?
Oh, muted.
Muted.
I'm wondering about the temporal component of the sampling. So when were you tracking the individuals? And then when were you sampling after the tracking, and how that corresponded with tick activity cycles?
Right. So the enrollment was more or less through the year. We didn't enroll. So there are people that got their loggers at the end of the fall and didn't actually start data collection until like into the winter. But in general, the vast majority of the data are from the fall and the spring and the summer. And then in terms of the sampling, you mean the tick sampling?
Yeah.
Yeah. So as James showed, the hotspots are really seasonally, a lot of the hotspots are very seasonally consistent. And so the sampling we're doing, routine spring, summer, fall, but there still were some hotspots throughout the year. Does that?
But so you were sampling like June, July, and then October, November, or when were you flagging is what I'm trying to
Yes,
figure.
correct.
Okay.
Yeah.
What kind of tick numbers were you seeing?
Some of the trailheads have been 12 or 15 per flag session. Scapularis. Yeah.
Any other questions? All right, so if that's all, Andrew and James, thank you for presenting today. All right, thank you, everybody.